At harvest time, no two fields are the same. Crop types, moisture content, field conditions, and weather all are important factors to consider when it comes time to get your crop out of the field. Jim Minahan has been following the harvest for over 15 years. He is a harvesting specialist with the Consumer Service Group at Case IH. Jim was there when the Axial-Flow combine concept was developed and has been with it ever since. It is our intention in this VISTA program to have Jim share his expertise to help you learn more about setting and adjusting your axial flow to meet your ever-changing crop conditions.
We're going to be discussing soybean harvest. We're going to talk about the header, we're going to talk about the combine separating area, and several adjustments. As we get into the soybean harvest, one of the things we should check before getting into it is the crop itself. Of the later years, the stems in some of our varieties still hold moisture while the pods and the beans themselves are down to an acceptable level of moisture. Also, when we get into some dry weather conditions, we should check some of the pods, which may be small and have a small bean in them. Other pods may have triples, and the bean that's next to the stalk may be a shrivel. Further inspection of our plant and opening up some more pods, we find where some little beans did not get any moisture and did not complete their development. Other beans were small. Here's a medium-sized bean. Also, we've seen some Mother Nature damage before it ever got to the machine. If you tried to adjust this out, you'd never get it. These type of conditions to the plant are going to govern how we adjust our combine, our header, in order to get a quality sample in the grain tank. And to begin with, we're going to start talking about the divider. One of our first adjustments that we're going to be making is to our header. We're going to adjust our header dividers. They're comprised of several adjustments, one of which is for our forward wing, which can lift the crop gently, reducing shatter in our soybeans. This loosening of this clamp, we can raise or lower this divider point. Our second adjustment is for the inner wing. It's held in place by this clamp. We like to position it inward such that the plastic pipe intersects with the tine on the end of the reel. This is so the crop can be pushed in, tine grabbing the crop, pulling it into the auger, reducing rapids that may occur on the end. The third adjustment is for the outer bat wing, held in place by this clamp. You can push it in or out, up or down. This wing is used to keep the material away from this end of the header so it doesn't hang or hairpin. The fourth adjustment is this clamp, which will allow the divider to be moved forward or backward depending on the position of our reel. Further adjustments to our row divider is a spring assembly and stop linkage. This linkage is used to allow the divider to float over the ground, allowing it to go over any obstructions that may be in the row. Just slight tension, so it's just slight pressure against the ground. This gives us enough pressure to separate the crop so that we'll divide it, either getting into the header for cutting or dividing it to clear our linkage that's on the left side of the header. The spring adjustment is made by using this draw bolt. Increasing the tension will increase its float, decreasing its tension will decrease its float. Further adjustments to our wing dividers is the lower stop, controlled by this linkage and slotted holes. This keeps a point in register with our cutter bar. Our real adjustments are, one, we would like to keep the reel level to our cutter bar. We can do this on the left and the right through the threaded portion in our lift cylinder. We can either raise or lower the reel. After we've done that, we want to make sure that the amount of thread shown here, according to our decal, is that if you have less than 2 inches of thread showing, we're going to put our exclusive auger lift pin in the forward hole, and if we have greater than 2 inches of thread showing, we will put the lift pin in the rear hole. Also, if we have a tine reel, as we have here, the pin for connecting the lift linkage and cylinder to the reel arms should be placed in the bottom hole. If the header should happen to be equipped with a bat reel, we would place the pin in an upper hole. Anytime we're working in and around our header with the reel lifted up, we should always put our safety stand in place. If our header is equipped with a pickup reel as we have here, we need to pay attention to how the cam is adjusted for our finger attitude into the crop. The reel does several things, one of which is to reach down, grab the crop, hold it as it's being cut, and delivered to our auger. The attitude of our tines can make a smooth transition to the auger, or it may not make it to the auger, or may carry it over. We like to have our tines with about a 5 to 10 degree pitch back so it kicks the crop into the auger flights. And to do this, we can loosen this cam on either end of the reel to decrease the pitch or increase it. A feature on our header is our hydraulic fore and aft of a reel, controlled from the cab on the go for varying crop conditions. Making further adjustments on our header, we're going to go to the knife hold down clips. And before we work on the header, we're going to put the safety stand down. Checking our hold down clips, we want a fore and aft clearance of 90 to 120 thousandths, as I'm showing here with my scale. Next, we want to check the up and down movement of the knife. Use a feeler gauge. We want 30 to 60 thousandths clearance between the section and our hold down clip. The fore and aft movement of the hold down clip is accomplished by slotted holes in the casting. The up and down clearance of the guard hold down clip to the section is controlled by a shim pack. The knife drive belt tension is maintained by these two idlers, controlled by this spring in relationship to this adjusting bolt. Spring length is 5.5 inches from the top of the washer to the bottom of the bracket. What you're seeing here is the header slip clutch assembly. This is used to protect the header auger and the knife drive assembly. The slip clutch is set at the factory at 180 to 225 foot-pounds. If the need should ever arise that we need to increase our slip clutch torque, we use these two bolts, one of which has been placed inside to the threaded nut that goes inside of our slip clutch assembly. With the aid of our cylinder rocking wrench, we can move the outer portion of the slip clutch housing 1/8 of a turn, increasing the slip clutch torque 17 foot-pounds. The tension on the auger drive chain is maintained by this spring. An important decal explains that our reel needs to be fully raised prior to making this adjustment. We're going to start the engine in a moment, and we're going to raise the reel, and three things are going to happen. This bolt is going to move, our idler arm and sprocket will move, as well as the auger driven sprocket. If we watch this sprocket hub, you'll notice it raises approximately 2 inches. On the 1000 series headers, we have PTO drive shaft connectors. Around the shaft is a protective shield of plastic and is held in place or retained from rotating by the use of chains at either end. Also, to carry the shaft while it's in transport, whether on a truck or a trailer, is this stub shaft. On the early production 1000 series flex headers, we had a 50-tooth driven sprocket for our auger, which drove the auger at 170 RPMs. In some conditions, this is a little bit fast, especially if you had some light, fluffy crop. So we introduced the 56-tooth sprocket, which drives the auger at 150 RPM. This increases the mat thickness as the material gets to the center of the auger, and better separation as it gets into the combine. We're going to go into our header auger adjustments, of which there are 3 located behind this shield. One is our fore and aft adjustment of the auger. We loosen this pivot bolt as well as these 2 lock nuts to allow the auger to be moved forward or back. This positions the auger close to our stripper plate, which we'll show you in a moment, or away. Second adjustment is auger height. This governs how high the auger may be off the bottom of our header. We like to keep it as close to the bottom as possible. We would do this by loosening these lock nuts, repositioning this wedge. Our third adjustment, auger finger timing. To do that, we use the assistance of our cylinder rocking wrench. This attitude changes the finger timing so it can make it more or less aggressive to the crop. In most crop conditions while harvesting soybeans, the finger timing as it's set at the factory is sufficient. What that is we have an interference angle between the face of the tooth and the auger tube. What this will do is draw the crop underneath the tube back into our feeder chain. But in the case of soybean harvest, we frequently get into tie vines or morning glories, and they'll want to wrap in the center of the auger. So we're going to have to take away a little bit of this aggression in the front and retie my fingers in the back so that the fingers will transfer the crop, being the green tie vine, back into our feeder chain. On the 1000 series flex headers, header angle is very critical. This assures us a nice short cut and even cut across the front. On both sides of the feeder house, we have adjusting bolts and draw bolts to allow the feeder face to be pitched forward. We like this angle to be as close to 10 degrees as possible, and with the aid of an angle finder, we can determine this 10 degrees. Now there may be some soil conditions which will dictate that we may want to roll the header back just a little bit, such as in mud, to put the sensitivity a little bit further back on our skid shoes. The feed conveyor chain tension is maintained by this pivot bolt as well as this adjusting bolt on either side of the feeder housing. The chain is properly tensioned when it has 1/8 to 1/32 of an inch gap between the flight and the bottom of the feeder house. An important point frequently overlooked on our flex headers is header level. We need to determine if our header is level with the separator housing. So you find a smooth, hard, flat surface. Then with a ruler you can measure the right and left end, determine which is high or low. Once you've determined that, you can loosen these 4 bolts, and for example, if the left end is low, we'll take and push the bolt out. If the right end is low, we'll take and shorten the bolt or pull the bolt to the rear. If we get caught in the field and do not have a smooth, level surface, we can use the separator frame and the main frame of the header to see if they're in parallel lines. And that would be the sight along this plane as well as this plane up here to see if these two are parallel. With our safety stand in place, we want to inspect our header latches, make sure that they're adjusted such that we have 50 foot-pounds of effort to close the latch. What makes our 1000 series flex headers function? Several things. One of which, mounted on the back frame, is an electronic potentiometer. Attached to the potentiometer is a cable which comes down and is attached to this feeler pipe which runs the width of the header. Also on the header, feeler bar, is that we have feeler pads. These pads rest on this frame holding our knife. Also attached to the back of the header and running forward are some leaf springs. There are several across the width of the header. They come out and are attached to the back of the knife. We have our skid pads which follow the contour of the ground. Then we have the knife itself, which is flexible to follow the contour of the ground side to side. For a better view of the items I've just pointed out on this header, let's go over to a display model, take a closer look. With our flexible cutter bar mock-up, let's go through the points that we pointed out on the header. Our potentiometer mounted to the frame, the cable connector going down to our feeler bar, which runs the width of the header, feeler bar pads, knife frame assembly, our spring, and our cutter bar. As we take the header into the field, lowering the header to the ground, the header is going to come to a designated height of cut. In doing so, it's going to position our feeler pads, feeler bar, cable, and our potentiometer. If the field is flat and level, the cutter bar should stay at that attitude. But as we go across the field, we come into a raise in the ground, the cutter bar moves upward, positioning the rod and our cable, which moves the potentiometer. In the cab, electronically, this will be monitored. Begin to pick the header up to clear this obstacle. As it goes on over it, the cutter bar starts to go down. The potentiometer is repositioned. Electronically in the cab, it will sense this and let the header down. On the 1000 series flex header, we have a couple adjustments that's underneath. One of which is this feeler bar pad. We want to make sure that it is against this knife support frame. And to do that, with the header raised, we want to make sure that the frame is all the way down against this pin. Also, ensure that this pipe has got all the clearance taken out of it. Loosening these bolts with the aid of a pin punch, you can stick it through the hole, wedging the feeler bar pad down against the knife support frame. Then tighten the bolts. Our second adjustment under the header is our leaf spring. The leaf spring's tension is governed by this bar. We can increase this tension by pulling the bar forward, or decreasing the spring's tension by pulling the bar rearward. What is the spring used for? The spring is used to give us ground tension for our cutter bar to penetrate stubble, such as if we had a drilled bean situation. There we would want a little more weight on the cutter bar, and in doing so we would relax the spring. As we got more into road crop or light stubble, then we will pull the bar forward, increasing its tension, thereby wanting to help hold up the cutter bar as it's going through the field. With the discussion of our cutaway and our header, we talked about the mechanical apparatuses hooked to the header to make the cutter bar float over the ground and its cutting attitude. These mechanical pieces are all joined together in their function through this cable to this potentiometer. Potentiometer is electronically connected to the cab and does several things. It gives us height of cut, the sensitivity to change from ground conditions, and an on and off switch. Now let's go up in the cab and review these switches. In the cab, the automatic header control portion for our flex header is controlled by 4 switches. Our header height for manual or auto, our header sensitivity, which gives the operator the opportunity to regulate how fast the header will respond to ground conditions. The header height switch, which regulates the height to cut up or down. And the normal header height switch for raise and lower. When the header height switch is in the manual position, our header switch responds in a normal manner. When we go to the auto portion, the header up is the same as it was when it was in the manual mode. But when we go to the downside, we trip the switch, it will automatically set the electronics so that the header will go to a preset height determined by the header height knob. To observe what our header height can be, we have an indicator on the right hand end of the header. From within the cab, we can regulate the height of cut above or below the center mark. With the feeler bar indicator in the center, we have 3 inches of flex up and 3 inches of flex down. If the indicator should be in the upper or lower portion of that quadrant, the ratio of flex up and flex down will change. Before we get into our threshing and separating adjustments of our axial flow combine, let's stop and think about rotary separation for a minute. Conventionally, as well as here, headers and feeder house the world over basically are the same. But in the case of our 1680 axial flow combine, the difference begins to change at this point. From the back of the feeder house, our crop flows through a transition cone before it gets into our concaves. This transition cone is shaped in the form of a funnel. Within this cone there are directional vanes. And with the aid of impeller blades that's on our rotor, we take the material from the feeder chain, positioning it in the transition cone, we begin to accelerate, control the mat, getting our crop ready to go out onto the concaves to be threshed. We've talked about whole kernel quality before. This is where it begins. Continuing with our threshing, separation, and on into our whole kernel concept, we're going to talk about our concaves. We have 2 illustrated here, one being our large wire concave. It is standard for our corn combines as well as used in soybeans. Our second concave is a small wire concave, mainly for wheat and other small seeds. In the case of the large wire concave, it's used in rice, milo, soybeans, and corn. Also, edible crops. If we should get into some large seeds, such as lima beans or big red kidneys, we can take every other wire out, opening up the concave, letting these precious seeds get through the concave and reducing our damage. Likewise in corn, we can do this when the need arises. Also shown on the second concave, or on a small wire concave, is this concave is a number 1, and it has a skirt to pick up the material from the transition cone and aid getting it on into the concave. Now let's go see where these are located. In our concave area, we have 3 sections. We have number 1 concave, number 2, and number 3. In the case of the 1600 series combines, we have added extensions to all 3 concaves, adding to our separation. Also in this area, we have directional vanes. These vanes are used to control the flow of crop over our concave. If we needed extra threshing, we can take the vanes and put them into the slow position, thereby taking a little longer for thrashing to occur and adding to our separation, such in a tough threshing condition. We can place the vanes in the forward position, which speeds the flow of straw up through the concave area, especially in soybeans, because it's a tough, hard stem to control. Also, in soybeans, frequently we will find growers, particularly hybrid seed and so forth, taking off straight rasp bars. And on the 1680, there are 4 in the first row. They will also take 4 off of the second row. What do these do? By removing these, we can further speed up the flow of material over the concaves, getting rid of the straw and reducing our splits and grain damage, because we can get the crop separated down into our auger bed and back onto the cleaning system quickly. The next section we want to talk about in our rotary separation is our separator grate area. Shown here was 3 examples of the types of grates that we use. The first grate is a keystalk grate, used standard in corn, rice, milo, or any other wet, tough separating crop. The second grate is our punch grate, mainly for small grains, especially wheat. The bars will be located over the holes on the underside. In the case of a grain machine used in soybeans, we may want to take these off for added separation. To get a little more fluffiness to the crop as it's passing over this type of grate, we could take these bars and mount them on the inside. If they're not needed at all, we can either mount them on the outside between the holes or put them in the toolbox. The third grate is our solid grate. The solid grate is used primarily in sunflowers or any other stemmy, pulpy type crop. Thereby, with it being solid, we can hold up these large particles that do not need to be down onto the cleaning system or congesting the cleaning system. The separator grates are located in this area of the separator housing. There are 3, number 1, 2, and 3. Also in this area are directional vanes, much the same as we had on the concave. These are used to aid in our separation if we should see extra kernels laying in the number 2 and number 3 section. Most generally when we move these as a set, such that we would go to the slow position, such in corn, aiding in their separation in this general area. In beans, normally we can get by in the mid position, but if we get in some green stemmy beans, we want to get rid of that stalk, we can go to the forward position, speeding up the flow of material. Also, we can take off the straight separator bars, which are mounted on the rotor in this area, and replace them with notched bars. These notched bars will grab this green material and pull it out of that rotor, aiding in the separation and getting rid of that tough, stemmy stalk. Sieves. The first one we want to talk about is our chaffer sieve. We're going to begin to use our cleaning fan, our chaffer sieve laying along this plane, to begin separating the grain from the large particles of chaff, sticks, and so forth. To get a better view of our chaffer sieves, we'll take a look at these over here. We have 3 examples shown. First, we have our corn slat sieve, 1 5/8" spacing, deep fingered construction, wide open design, standard on our corn machines. It is also used in other seed crops, demanding a large opening for quick separation in the cleaning system. Second is our standard grain sieve. It's a closed slat, 1 1/8" between tips to tip. It's a shallower finger. It's mainly used in wheat and other small grains. Our third sieve is 1 5/8" spacing, closed slat, mainly used in green milo and so forth, or similar crop conditions. For a closer view of our vein construction, we have here on the top the 1 5/8" corn slat, which shows a real deep finger in its design. The bottom slat is the 1 1/8" grain or 1 5/8" slat design. You'll notice that this hole is much shallower. In summary, what is a chaffer sieve? A chaffer sieve is like an air valve. It controls airflow within our cleaning system on the upper end. By their design, they can let grains fall through, as if they're rather dense, as well as unthrashed heads and so forth. While at the same time, the airflow is keeping the lighter chaff particles airborne so that they can go out the back of the machine. As well with the vane design, if we have large sticks, cobs, and so forth, they will work towards the back of the machine and fall out the back as well. Further down into the cleaning system, we have our shoe sieve, which lays across this plane. To better get a look at that, let's take a look at these sieves here. Shown here is our standard grain sieve, 1 1/8" spacing. The second sieve is our option shoe sieve, 1 5/8" closed slat design. This is used for high capacity, such as corn, edible beans, and so forth. For a little better look at our vein construction, let's take a look at these. The upper one, with the short fingers, is our standard general purpose shoe sieve at an 1 1/8" spacing. The next vein is our option 1 5/8" closed slat design for use in corn or other seeds requiring high capacities. We've seen and discussed several items within the separator and the cleaning system. And now we want to put that together by referring to the operator's manual, machine setting for various crops, one of which will be soybeans. These machine settings are a starting place because varying crop conditions may dictate that we increase or decrease various settings. As we look at 3 samples of grain here, our first sample indicates some possible over-threshing. Part of a pod with a bean in it, a broken stem. We have some loose pod. We have some cracks and some splits, indicating that our rotor speed may be too high or also insufficient airspeed. Our second sample has a few splits, but typically shown here is once in a while we have the upper pods which are tough to separate, indicating that in this particular sample we may have the shoe sieve too wide open. And with some of the splits we may have too high a rotor speed. Our third sample, it's a nice clean sample, relatively free of splits, no foreign material, a sample we like to take to the elevator or put in our storage bin. Having taken our operator's manual and preliminary set the machine for soybeans, we're going to go into the field now and do a kill stop. What is a kill stop? Kill stop is to take the combine at its normal harvesting rate and shut it down using the brakes, throttle, and the ignition switch to kill the machine completely loaded. This gives us a good view inside the machine, what's happening with the crop that's being harvested. This gives us a chance to look at how the material is thrashed on the concaves. We can look at separation on the grates. We can look at the load on the cleaning system. Also walk and look what's in the tailings elevator. Should mention that the instant that you kill the machine, you should restart the engine to dissipate any heat that's in the engine, let it cool down to a normal shutdown state, and then shut the engine off again before you get out of the cab. Also, that once we've made our inspection, is that the machine is full. A lot of people will think that it's slugged. It is not. It was still in motion when it stopped. So by restarting the engine, setting the throttle at about half position, engage the separator switch, as the rotor begins to move the material through the machine, is to slow it down to just above an idle so that the grain that was thrashed and trapped inside the machine stays there. A lot of people will immediately go to high idle, and what will happen there is that the load of grain that's in there most likely will be thrown out of the machine. What we want to do is save all the crop that was harvested at that moment and put it in the grain tank. While we're doing the kill stop, we're also going to be using a grain check box to check for losses that will be coming out the back of the separator. Also, as we stop the machine, we're going to pick the header up and back the machine up about 10 feet so that we can look on the ground after our cut to look for shatter loss that may have been caused by the reel or our knife. Also, we'll be going out into the standing crop looking for loss that may already have occurred from Mother Nature. As it gets dry, the pods may be already open from rain, hail, and so forth. Looking into the concave area after a kill stop, we can look at and see several things. We can watch how the straw is moving through this area. We can look at the texture of the straw to see if it's being thrashed. And in the case of soybeans, usually our feeder house and impellers do a lot of opening of the pods, so our concave area basically is a separator. We can look at the straw, make sure that it's not lazy, remembering that some of our varieties of soybeans have a tough, damp straw, but the pods are dry as well as the beans inside. So we want to be looking at that. We can look, tickle the underside, looking for any loose kernels to see how we're doing our thrashing job. Look at the texture of the straw. Make sure all the loose pods are opening as they're going through the separator housing. Now that we've looked at our concaves, let's go into the separator grate area. In the separator grate area, we're also going to be looking at texture of straw, making sure that we have no congestion or compaction of the straw in this area. We're also looking at pods, make sure that they're free, loose, and pick up some straw off the grain pan Make sure the pods are open. And this time you can check and see the moisture content of the straw. If it's damp and tough, could indicate that we need some more rotor speed, or we may want to move our directional vanes to speed up this flow of material through the separator area. Also at this time, we could install the notch separator bars, which will further aid in moving this damp, tough straw out of the separator grate area. Coming from the separator grate area, we're going to go into the cleaning system and look at the chaff mats that's on the chaffer sieve and also the shoe sieve. We'll also be looking at the straw that's being discharged from a discharge beater, and we'll look at the material laying on top of the discharge pan. Looking at our cleaning system, this material here is straw that's been discharged from the discharge beater and fallen down when the engine and rotor stopped. So we want to pick those pieces off, trying not to disturb the chaff mat that may have laid underneath it. Also on this discharge beater bottom, well, look underneath the straw and see if there's any loose kernels. Going up onto the chaffer sieve, grab a handful of chaff, look at it. What we see here is the seeds have fallen through. But again, what we're looking for is unthrashed or unopened pods. Good sample. Again, we can check the texture of the moisture in the straw. And viewing down through the chaffer sieve, we can look at the shoe sieve and see what the material looks like down there. Okay, the heavy particles, unthrashed, and seeds have fallen down onto the shoe. Unopened pods can also work to the back of the shoe sieve and get into our tailings auger. So now let's go out and look and see what the material looks like in the tailings auger lower boot. Coming to our tailings elevator boot, we're going to be looking at the texture of material that's getting over the back of the shoe sieve. We can check the texture of pods in this particular instance. Looking at this one, it's rather tough. In there is a very damp bean. It's kind of squishy. Another pod, it's also kind of tough, but not nearly as much as the earlier pod. Needs to be rethrashed. We see some small sticks, and we also see a split or two. These indicate that we may have too high a rotor speed. And with just the return of these damp pods, may be sufficient to finish the thrash. If we try to increase our rotor speed too much with these high moisture pods, we may get more splits. Also in this sample, we see some undeveloped seeds, which are light green in color, indicating we may want to use some more fan speed to blow them out. Likewise, we see pieces of the pod, indicating a little more fan speed, and we could blow these out. If we had larger pieces of stalk, it may indicate that we had too high a rotor speed or the concave too close. Now that we've looked inside the machine, let's go back here and look at our grain loss box. The box is 4 foot wide, 1 foot front to rear. Within this box, we've captured all the straw chaff that came out of the back of the machine. Also, we've removed the straw spreaders so that anything that's discharged will land in this box. In the operator's manual, there is a seed loss chart for various seed size. Since we're in soybeans, we would look in the chart under soybeans for the amount of grain per square foot caught in this box. We'd also have to match the separator width, which is a 1680 in this case, and a 20-foot header. Now let's divide this out, being careful to keep the straw that fell in the box with it. We want to agitate it so that any lost seeds from the separator is maintained in our box. While we're separating the large particles of straw, we also want to be sensitive to unthrashed pods, because this is going to add to our loss also. Now that we have removed straw, chaff, particles from our box, we can better see what our loss actually is from the separator housing. Also can study it further and see that there is some splits, indicating that we possibly have too high a rotor speed or our concave is too tight. Also, here are some undeveloped seeds, as if the plant ran out of water or some other deficiency. If we see this, more than likely we could probably see some seeds that are going to be in the size between these two examples. So we may want to use a little less fan speed so that we do not get into a situation where we'll be blowing the smaller seeds out. Now that we've checked our loss in our grain loss box, let's go up to the header and see what the reel and knife shatter was as it got into the beans. With our machine backed away from the cut, we're going to get equal distance between our drive tires using our grain loss box once again as a tool to measure off 4 square feet in front of the separator portion of the combine. The beans that are left underneath in this trash should represent what our reel shatter and knife shatter may be. We can refer to the operator's manual and seed loss chart and check and see how many seeds it takes per square foot in front of the separator to equal a bushel acre loss. Now that we've seen what our loss is from the header, let's go into the standing grain and see what Mother Nature may have thrashed out there for us. Going out into our standing grain, we want to look at the pod structure of the plant, make sure that none of the pods are open, and to look under the ground, under the leaves, make sure that Mother Nature hasn't deposited some beans up here before our header got there. Now that we determined there's no loss here, let's go up into the cab and look at our grain loss monitor. The grain loss monitor is located in the right-hand front corner of the cab. On the monitor we have 3 control knobs, one of which is for grain size. We're in soybeans today, so we'll set it to the large seed selection. Second control knob is for the sensitivity of our pads on the chaffer and rotor. Our sensor control knob to turn the sensors on at the chaffer only, or at the rotor position, there we monitor rotor only. or to the both position. Now we monitor both circuits. A light bar containing 4 lights, 1 light for each sensor. These will flash as something is striking them, whether it be chaff, seed, stalks, and what have you. A meter, which can be set in the middle of the green or the beginning of the green, per however we want to monitor the sensitivity of the pads to be functioning. This is all activated with the ignition switch. As I turn the switch on, you will notice the needle goes through a self-check of the complete system, then goes back to 0. This is done each time the ignition switch is turned on or the selector switch is taken from off into the rotor, chaffer, and both circuits. Now let's go into the field and watch this work. As we go through the field with material, whether it's stalks, beans, chaff, what have you, these lights will light up on the bar. Also, from a pre-designated setting of our meter position, you can have the needle set at the top of the green, the middle, or the base. Now as we speed up, the needle should lower. If we should slow down, the needle will come up to match our ground speed and our throughput. It'll go over and come back until it matches the time. As we come back to normal throughput, we can adjust the gauge according to our sensitivity control knob. Now that we've reviewed our header settings, separator settings, cleaning system, look at our losses, our grain loss monitor, let's go cut some soybeans.